Pygame, and we will be building starships and asteroids again. In this first section, we will be building a three-dimensional game. We will be using Python classes to create starships and asteroids. We will add collision detection, and then we'll be destroying asteroids. In this first video, we will be building a three-dimensional game. We will continue to use the Pygame module. We will be installing the Python Numpy module. We'll use the Numpy module to calculate 3D space, and then we'll be creating a three-dimensional game. So let's start by reusing the code from our last section, and we'll start with the minimum amount of game we need. This is all, this is the minimum. We do the import statements in it, set the caption, set the window width and height, get a clock, set the frames per second, declare a function, call the function here, and this is our main game loop. And when we exit the loop by clicking on the X window, we get out of the loop, and Pygame quit cleans us exits cleanly. So let's run this. One thing different is I have a new image here for our space game. So when we run it, this is all the code needed to create this window using Python and Pygame. So next we're going to install the Python Numpy module. We do that via pip install, as always, for most of the time. And Numpy is an advanced Python module to work with numbers, and num is short for numbers. So I already have it installed, but the command is pip install numpy. When you run it for the first time, you should see some slightly different output, like installation was successful. So I'm rerunning the installation, and it should say, yeah, it's already satisfied, it already exists. So let's import it. And often you can see on the internet, like people alias it as NP, shorten it, so import numpy, often seen as NP. So let's import it. We're not using it in here, but it's a good idea if you import a new module, just to, if you install a new module, to import it and run it and make sure that you don't get any error messages. So this looks good. Our Numpy installation was successful. We can draw 3D lines. They're not really 3D, but they make us look like we have a 3D surface. We use Pygame, draw a line here, and then we go to game surface, a color, and I've created some module level global variables. So the bottom line is actually a tuple, so I have the star, the asterisk in front of it that unpacks the tuple, because draw line requires a start and an end position to draw the line. And so my bottom line here is a tuple, left bottom M, left bottom Y. Yeah, those are coordinates. Actually, they are tuples themselves. So this is 10, and then a height minus 10. As you can see, I'm trying to reuse the code, and the variables don't create the same numbers all over the place. 10-year experiment. But the main thing is we use those module level global variables, unpack them here, use draw line, and then we can draw some lines onto our canvas. So now we have like a border line. It's almost like a window, kind of adds a little bit to the 3D starships we'll create. So now that we have a nice space screen display background, we want to create some three-dimensional shapes. And the mask for this is actually a little bit complicated, a little bit complex. Pygame has some 3D support, but not enough, it seems. So anyway, it's getting a little bit complicated. But the main thing, I'm not going to go into much detail. The main thing is we need a rotation matrix, and it accepts an angle X, Y, Z. So we're passing in X, Y, Z. And then it does several calculations, sinus, cosine, and then it does this fancy thing here, and this is well known. I couldn't even explain to you what this does, but you can look it up on Wikipedia, rotation matrix. This is a trick. We pass in our current position, the angle of the rotation actually, and it gives us the new position. And yeah, so we'll get into that in a little bit more detail a little bit later. So for now, let's just run a few examples. This one is down here. We're drawing the shape. Here we're calling the rotation matrix. We have rotation XYZ, a list actually. So this one begins with 3 zeros, and they represent X, Y, and Z. And we update them in this rotate function. So we pass in the axis, which will be index position 0, 1, or 2 for X, Y, and Z. And then we do plus equal degrees, the degrees of rotation that are being passed in. But plus equals in this case doesn't mean that we always add to it. We often pass in negative degrees, and positive and negative in this context means only rotation in a clockwise or counterclockwise direction. So plus minus can also subtract. It can do both things. So here we have the key presses, and we call the rotate function whenever we press the keys. And this is like the keys I'm using for this time. So it's the top left keys on the keyboard, 6 of them. Q, A, W, S, E, D. So those are top left on the keyboard. And then a little bit extra, more for gimmick, the space bar. So that does something fancy or funny. But yeah, so in order to get any rotation going, use Q, A. This is here for when X is being updated, counterclockwise or clockwise, up or down. Y is then W and S, and then ED is for the Z axis. So let's run this example. So we are creating some vertices, and I call them shape points. Other people in the industry, they call them probably much more correctly edges. For me, they look like points of a shape because we're drawing a shape. So passing, here's where we're using Numpy. We need this to turn our tuple of tuples into a Numpy array. And then we can do some 3D. Without that, we couldn't do it. So we only use Numpy here, but you can use Numpy in many places for many great things. But we keep it as simple as possible. So NP here, Numpy. Yeah, let's run it. And I have to see how many fingers I can move here. So this is our beginning. Q, A, W, S. So we go into opposite E, and D. And we can also combine them. Move them up and down. And this is 3D. I mean, this is because of the rotation metrics. This truly is 3D. And our green box is not 3D, that's 2D. But you can see that the rotation metrics calculates the XYZ rotations from the key presses. And when we press the space bar and hold it, we get something funny because of the coordinates I put in there. Yeah, so that's pretty good for a start. So this is basically the same stick, but we changed some of the plus and minus ones in what we are passing in the vertices. So this, for whatever reason, it looks like the same, but it behaves differently. So when we now run it, we can see that the stick is dancing around the center. And let's see. Trying to press many buttons here with 2 fingers. So when I press the spacebar, though, it's more obvious. You can see it's not moving back and forth. It is moving back and forth, but it's stuck in the center. So it's centered in the center of the screen. The previous one didn't do that. So yeah, that's pretty neat. In this video, we built a 3-dimensional game, or at least the beginning of it, and we continue to use the Pygame module in our code. We installed the Numpy Python module and used it, and we used it to start calculating 3D space. And in the end, our game, we created a triangle and some sticks that were truly and are truly 3-dimensional.